Does that bring us back to what you were talking about early on in this conversation around the early years being so important?
So, yeah.
Because that core group probably says, actually, no, you're not allowed in here.
Yes, so that's really important. So if we look at, what we know about how the microbiome changes with age, clearly the first few years of life are critical because it's then building up, it's reaching its sort of life, its point at which it's not going to fluctuate much.
Should we be doing something during those early years?
Absolutely. I would argue if you want to change the microbiome, it should be done in the first 3 or 4 years of life.
Wow.
That is the best intervention.
Wow.
And the things that will promote the development and establishment of a healthy microbiome are how you're born, where you're born, and how are you nurtured. So, vaginal delivery, cesarean delivery, hospital, home, breastfed, bottle fed. Those are key factors in the establishment of a healthy microbiome. And, we can enhance that by providing to those individuals who don't get the benefit of those beneficial things occurring very early in life with the microbes they're missing. And that should be lifelong. If it's done in the right way, right number of intervals, right dosing, et cetera, right mixtures, you should be protecting people, that individual, lifelong, because they should be stable and carry with them through their life.
The challenge and there's many challenges, but I think the key one must be, even if you develop this beautiful supplement or drug, proving
it's a long-term study, isn't it?
Yeah, so I knock on the doors of investors all the time. I say, hi, I'm James, and I've got this great idea. I think it's going to change the world. We've got some good data, and here's the trials. And if I was to go into an investor and say, well, I've got this is going to be big, right? Everyone's going to get this if they were born through a C-section or whatever. And there's going to be less allergy, less obesity, less autoimmunity, but I need you to buy into me doing a 50-year study.
Yeah.
They'd all be going, no, we can't do that.
Yeah.
Most investors want a return in 5 to 10 years. 10 years is really pushing it. 5 years is more standard.
And there might not be a tangible
endpoint. Yeah.
So there is a benefit to being in a research institute where you have that, where you've got sustained long-term investment and the support of, a stable funder, like the BBSC, for example, in our case, where you can say, this is our strategy. To do this, we need to undertake these studies. And, we need as long as it passes peer review and everything else, they will buy into that to allow us to do that.
You need the patient capital.
We need the patient capital, exactly. So that's one way you can do it. But again, not everybody works in an institute has a benefit of that sort of long-term sustainable. And of course, that allows you to retain key skills, people that can do this, highly trained, so you've got confidence you'll be able to get some end product.
So what is your research focused on at the moment? And if I have missed any key part of your journey, let's go back there and let's just explore that before we're talking about the now. And we've got lots of difficult questions to touch on as well still.
So when I went back to the UK around 2000, I went to Leeds because there was some bacteriologists there who were really interested, a guy called Keith Holland, who worked on acne and the bacteria that causes acne. And he was very helpful to me because he worked on a very difficult to culture organism. And I wanted to work on an anaerobic bacteria that grow in the gut. So he worked with me for several years, 3 or 4 years, to basically build up the toolkit so that we could start working with difficult to culture microbes in the gut. And then unfortunately he retired, and the university in their wisdom decided they were going to hire structural virologists rather than classical bacteriologists.
Okay.
So that was the time that the Institute of Food Research, as it was then, came knocking on my door, said, would you be interested in developing a gut health program? And I knew they had a lot of really good microbiology, basically in the food side, working on lactobacillus, probiotic bacteria, but they're also working with anaerobic bacteria. What they didn't have was more the gut side, the humans, the host side, if you like.
Right.
So when I went down to IFR, we sort of built a program around gut health, and it was microbiology, host health, immunology, etc. And that's then evolved into the Quadram Institute's programs since then, where we've now got sort of good strength on both the host side and the microbe side. And the microbe side is looking at fungi, bacteria, viruses as well. So we've taken the integrated microbiome approach. So that really changed the Institute of Food Research into more fundamental gut microbiology, gut microbes and health program, which it is now. But I never lost my own personal interest, which is, how does the microbiome work and how does it interact with us, the host? And it's not through direct physical contact, so we're not constantly acquiring microbes from the gut and then processing whatever.
Yeah.
There's that sterile barrier. So what else can get across that? And
so can I just press you on that a little bit? So that's the sterile barrier. So, and I'll ask you in the context of FMT, because I'd always thought that in an FMT, and for the listener, fecal microbiota transplantation, if you've not heard of it and this is the first time hearing it, go to Biome Bites episode number 1 where I talk about intestinal microbiota transfer FMT. So I thought that when you instill this, I'll call it ecology, the immune system recognizes it as being foreign. But I think what you're saying is only if it comes into contact with cells that are innervated or immune cells, right? And they're not going to because of the mucin.
Correct.
Huh.
Yeah.
But some of them might find their way. So
that's always the danger because, like I said, there are people out there that believe all human diseases are related to changes in your gut microbiome. And so how does that work? It's still got to communicate, with the host and drive these nasty responses. So I think the underlying cause is what we call a leaky gut. There are breaches in the barrier.
And that barrier is the mucin.
The mucin.
And the epithelium.
Yeah. Or even worse, if you're disrupting both your epithelium and the mucus at the same time. And this could be through, drugs, medications,
alcohol.
Yeah, these things over a long period of time will make the barrier leaky.
Yeah.
And that then, depending on what's getting across the leaky barrier, could then trigger all sorts of nasty reactions. And the gut is a massive sensory organ. It's not just got the biggest immune system in the body. It can also make virtually all known neurotransmitters. It's your second brain. It's packed full of neurons, the enteric nervous system, and it's packed full of hormones. So it can produce all these hormones.
When people say gut feeling.
I get this gut feeling, absolutely right.
Gut instinct.
You get the butterflies in your stomach, that's all these neurons in your gut firing off. And that could be to say, fight or flight, or stop doing what you're doing because this could harm us.
Wow.
So depending on you stimulate your immune system, your second brain, your hormonal system in the gut, you can get different signals going all over the body.
Wow.
And of course, a lot of them will end up affecting the brain and maybe how you behave and respond. So it's a massive sensory organ.
This gut-brain axis then, should we just touch on that briefly?
Yeah.
So it's a bit of a buzzword at the moment, isn't it?
It is.
What does it mean to you?
So classically, it's the connectivity between the brain and the gut via a major nerve called the vagus nerve. And that's a bidirectional nerve. So the gut is communicating with the brain is communicating with the gut, usually to regulate things like peristalsis, motility, and the brain is signaling via that nerve to say, we have a problem, we need to change peristalsis, we need, diarrhea, for example, you get a massive brain causing massive peristalsis and trying to get rid of the toxins. And it's feeding information to the brain about what's going on in the gut, basically. So the vagus nerve is there anatomically.
So that's a key element.
That's the key element. Direct connection.
Yeah.
And then you've got the other systems, so through the immune system and the vasculature. So if things get across the gut into the bloodstream, they can then circulate around the body, get to the brain, cross the blood-brain barrier, influence the brain activity. Hormones, of course, neurotransmitters, they'll all work through the nervous system, other nervous roots to influence the brain. And now, of course, it's, what's triggering all these reactions to stimulate these pathways?
Right.
And we now think that a major part of that is your gut microbes, what you have there and how they're interacting with the nerve cells, the hormonal cells, the immune cells to trigger these things. And as I said earlier, we now know that gut microbes can make their own neurotransmitters, so they can directly influence the brain if those get into the bloodstream.
What triggers them to make them? Do we know?
We don't really know. We know that sometimes it's in response to stress.
Wow.
So it's interesting because some stress hormones, for example, acetylcholine, can be utilized as growth substrates for certain types of bacteria in your gut. And interestingly, salmonella is one of them.
Huh.
So, there are
Classic
microbes
baddie.
which can act in response to the hormones we produce. And then in response to various stimuli like an infection or something, that will cause bacteria to make neurotransmitters or hormones to change this. So there's probably a variety of stressors that can trigger this production.
Incredible. So really, it is a fair statement to say, trust your gut feeling, gut instinct. I'm gutted.
Yep.
So it all stems back to the
not
gut.
far off the mark there, actually. Yeah.
Amazing.